Alice arrives with $10,000 but takes a completely different approach. She's going to bet just $1 on red, over and over again, until one of two things happens. Either she's up exactly $100 or she loses everything. This might seem like a much safer strategy. After all, she has 10,000 chances to slowly build up her winnings. She only needs to accumulate 100 more wins than losses before her bankroll disappears entirely. With nearly a 47.4% chance of winning each individual spin, surely her odds are much better than Bob's, right? Alice has only a 0.00265% chance of winning $100. That's not a typo. It's about 26 chances in a million. Despite her $10,000 bankroll and conservative approach, it's almost certain she'll lose everything before making her modest profit. But the real shock comes with Carlos. Despite his $100 trillion bankroll, literally a million times larger than Alice's, his probability of success is essentially identical, 0.00265%. The difference between their odds is so minuscule that you need a high-precision calculator just to detect it. For all practical purposes, the person with $10,000 and the person with $100 trillion have exactly the same chance of winning $100 using this strategy. However, there's a catch that explains why casinos always remain profitable, despite some players having almost 50% chances of winning. A total of 1,260 units lost. The math is stark. 1,260 units lost versus 185 units won. The total losses exceed the total wins by more than 6 to 1. This is how casinos make money. Not by ensuring every player loses, but by ensuring that when players do lose, they lose much more than the winners win. Every casino game can be reduced to a fundamental mathematical concept: expected value. This represents the average amount you can expect to lose per bet over the long term, and it's built into every game structure. If heads means you win 90 cents and tails means you lose $1, your expected loss per flip is 0.5 times 90 cents plus 0.5 times negative $1 equals negative 5 cents. This represents a 5% house edge. You can expect to lose 5 cents for every dollar you wager over time. Real roulette has a house edge of 5.26% on double zero wheels. This means that over time, you'll lose $5.26 for every $100 you wager, regardless of whether you bet on red, black, odd, even, or individual numbers. The house edge is always positive, meaning you always have a negative expected return. They just need to ensure that over time and across all players, the mathematics works in their favor. Don't gamble at all. Every game is designed with a house edge that guarantees one thing: over time, you will lose. Math.